Proteins are essential to the function of all living things, so when they stop working, so does the organism. It is well known that the shape of a protein directly affects its function, so when it becomes misshapen, it usually stops working. Now, what's worse than a misfolded protein that no longer works? Well, one that can aggregate in the brain with similarly misfolded proteins to cause incurable diseases. But in order for this to happen, a prion is needed. Now, you must be wondering, what is a prion? Well, a prion is a misfolded protein that is able to transfer its misfolded shape to other proteins of the same type. When these prions aggregate in the brain, it can cause prion diseases. The most common example of a prion disease is Creutzfeldt-Jakob disease, which can cause personality changes, memory loss, anxiety, and depression. Some people can lapse into a coma, but all cases eventually lead to death. Prion diseases can be transmitted in between species by contact with infected animals or by consuming contaminated meat. The idea that a protein can clone itself without going through nucleic acid intermediate goes against everything we know about transmissible disease. Even the simplest viruses contain DNA or RNA. Because prions appear to be infectious proteins that can clone themselves, the central dogma seems to not apply. One of the reasons scientists are skeptical of this protein-only hypothesis is that these diseases come in distinct strains that differ in symptoms, regions of the brain that they affect, and incubation periods. Skeptics argue that these differences are due to mutations in nucleic acids, which would then be proof that prions do have genetic material. Another reason is that amyloid diseases occur in the same way, when amyloid fibers build up in the brain and are not broken down, which then leads to neurodegeneration. Alzheimer's, Parkinson's, and Huntington's disease are all examples of this. But none of these diseases are infectious, leading to the argument that a protein alone is not enough to cause disease. Transmissible spongiform encephalopathy, or TSC diseases, include scrappy and mad cow disease in livestock and Creutzfeldt-Jakob disease in humans. The central and disease-causing part of TSC diseases involves the mammalian prion protein, or PRP. During infection, the regular form of PRP-sen, which is sensitive to breakdown by an enzyme called proteinase K, is converted to an abnormal form, which is resistant to proteinase K. This form, PRP-res, piles up to high levels in the central nervous system of the infected host. PRP-sen expression and PRP-res pileup are both believed to be involved in the degeneration of the host's brain. PRP-res infectivity, combined with the lack of any bacterial or viral association with TSC diseases, leads to the hypothesis that PRP-res itself is the infectious agent. As you can see, prion diseases are fairly mysterious, with the direct cause and transmission still unknown. There are currently no available treatments and only supportive care for symptoms. But there's ongoing research to find out more about these mysterious proteins, which will hopefully one day lead to an answer and cure. I'm Olivia Feeney, and thank you for watching my video.